As you see here, we want to graph 2 times the cosecant of theta over 3. When we have a cosecant or secant function that we want to graph, we often, especially when we're first learning, start by graphing its reciprocal function. So the reciprocal of cosecant is sine. So we're going to start actually by graphing y equals 2 times the sine, and we can rewrite this as 1/3 theta. And we're going to graph that function, and then we use that graph and the idea of the reciprocal functions to graph y equals 2 cosecant theta over 3, or 1/3 theta. So let's go ahead and get started with this one with sine. We're going to look at phase shift, period, amplitude, and vertical shift. When we do amplitude, this is the amplitude of the sine graph. We don't really have an amplitude for the cosecant graph, although it's definitely used, and we'll see that shortly. So graphing the sine function, first we look at phase shift. Well, phase shift, it's what's added or subtracted from our independent variable, which here it says x, but again, we're using theta. So there is none. There's nothing added there to theta. The period, well, period for the parent graph of sine, just y equals sine of theta, is 2 pi. So to find period of this function, you take 2 pi divided by what's multiplied by theta. So I'm going to make sure we're going to put theta here is what we're using. So that's the 1/3 here in our function, the 1/3. So it's 2 pi divided by 1/3, which dividing by 1/3 is the same as multiplying by 3. So we have 6 pi. So I should have started this a little bit earlier. So the fact that there's no phase shift means our starting point is at 0. And then we find our ending point. We find our ending point by taking our starting point, which is 0 in this case, and adding the period. So our ending point is going to be 6 pi. And then we find our quarters. So I'll mark those there. This one's pretty easy. 6 pi divided by 2, like half of that is 3 pi. Half of that is 1.5 pi. And then this would be 4.5 pi. As mentioned earlier, you can always take the entire period and multiply it by a fourth, because we're dividing it into quarters. And this is 6 pi over 4, which is 1.5 pi. And so we take our starting point, add 1.5, add 1.5, add 1.5, and add 1.5. We can also go backwards. So this is negative 1.5 pi, negative 3 pi, and we'll go ahead and move on to our amplitude. So our amplitude here we see is 2. So we'll put 2 for amplitude. So we'll count up to 2 and down to negative 2. And we can put our dashed lines there as our guidelines. And then we graph. We always graph after the amplitude. And so with sine, we know at our starting point we're at 0. After the first quarter, we go up to the highest point, which is 2, back down to 0, back down to negative 2, back up to 0. We'll work our way backwards as well. And this red graph is the graph of sine, which we have done before. We've graphed sine. But we were not asked to graph sine, we were asked to graph cosecant. So from here, this is how we can graph cosecant. So I'll put our answer here in blue. So this is going to be in blue. We will have a vertical asymptote. By the way, I should have written this in here. There's no vertical shift. So we didn't have to relabel anything. So this is 2 and this is -2. So once we're going for cosecant, wherever there's a 0 on the original function, 0 will go to being a vertical asymptote. So we're going to put vertical asymptotes wherever the sine graph crossed 0 or crossed the x-axis. And then what we do is at each of our highest and lowest points, so I'm going to start right here. We start at that point and we go towards those vertical asymptotes. So things that are below the x-axis go down and parts that are above the x-axis go up. And so we can graph this cosecant function. And we'll put this part here. And so once again, that blue section, not the red section, but the blue section is the graph of 2 cosecant theta over 3.